RAM is used to write and read data values as a program runs. RAM is a volatile memory. All variables used in programs are allocated here. It is not sequential as well. So that means you cannot go in sequence. You cannot fetch the details using index, right? Those where we have to aware. Stack is allocated in RAM. The stack memory that we discussed, right, it is a part of RAM. It is not a separate memory, that we have to understand. Stack stores information chronologically, that also we know. It follows the concept of LIFO, used during the function call and interrupt service. This stack memory is used when there is an interrupt, when there is a function call. In that time only they use that memory. Stack memory for the concept of LIFO, last in first out. Whatever that you pushed to stack last, that you can fetch first. Incremented when the data is pushed, sorry, actually it is decremented. It is not incremented. Decremented when data is pushed. When you push some data to stack, it will decrement itself. When you pop it out, it will increment itself. Usually stack memory is number of location. So it is not in terms of kilobytes, megabytes, something like that. They will have a very limited memory to store the details in stacks, because usually they used to hold address of content of program counter, and then address of the program memory when the interrupt occurred. So it used to store these address details only. So it doesn't require much memory. So they will reserve part of RAM for stack, and they use that memory to store these details. Right. Then every microcontroller used to have IO ports. What is IO ports? They are pins in a microcontroller. You can use those pins to output digital outputs like one, active high, active low, something like that. Again, you can even digitize. When there is an active high input, these ports can detect it and will convert that to one, right? That is, active high is digitized to 1 and active low is digitized to 0. Even that is possible using these ports. Usually in a microcontroller, you will have more than one ports, right? It depends on the microcontroller, right? These ports support different standards and different modes. Let us discuss them. Broadly, the ports are classified into parallel port and serial port. If it is a parallel port, to exchange or to transmit each bit, it requires an independent pin, right? If it is serial, within using a single pin, you can transfer any number of bits. Because they are sequential, they are transmitted one after another, right now. So number of pins required to do a serial port communication is very less compared to parallel port, right? Mostly the parallel ports are not used nowadays. People are using only serial ports. Right. Again, the mode wise, the ports are used in synchronous mode, asynchronous mode. Right. In synchronous mode, when you want to use a serial port standards, right, they require a synchronized clock. In order to do every bit exchange, you require a clock signal. Right. The example of synchronous serial port that we have in microcontroller are serial peripheral interface, and then MCBSPs, synchronous serial port, multi-channel synchronous serial port. These are the available synchronous ports in microcontroller. With respect to asynchronous port, we have serial communication, UART, USART, I2C. These are examples for asynchronous serial port. So using these ports, we can exchange the signals with other microcontroller or from microcontroller to a computer, right? A microcontroller to another device, which is operating in different standards or protocol. So for that, these ports are used, right? Again, these ports are very important. They are used to transmit control signal, right? The interfacing of keyboard, interfacing of LCD, interfacing of stepper motor, interfacing of LEDs, everything happens using these ports only, right? So mostly microcontroller will have a lot of ports, right? Here we have an example. In FIX 16F877A has 5 ports. Each port has an associated TRIS register which control the direction. I told you can use port pins either input or output. When it is configured to output, you can transfer digital outputs right now. That means you can make that particular pin to high volt. You can make that particular pin to low volt. This is controlling the port pin as output pin.
Tired of complex GST calculations and messy stock management? There's a simpler way to run your business. Introducing the GST-based inventory and billing system from Yahasiya Software. This is the all-in-one software you've been waiting for. It automates your billing, tracks your inventory in real time, and produces accurate reports with just a few clicks. Spend less time on paperwork and more time growing your business. Do you want a demo? Call 875-451-8745 today, and grow your business to the next level.
We are sending output from the microcontroller. It is also possible to accept high input or low input and convert them to 1 or 0 in the microcontroller. For that, we have to configure that port pin as input pin. To do that configuration, every microcontroller has something called as data direction register. In case of FIX 16F77A, that register is called as TRIS register. For each port, they will have TRIS A, TRIS B, TRIS C, TRIS D, something like that. By setting particular bit in that particular register, you can make particular pin of that port. Each port will have 8 bits maximum, right? 8 bits per port, that means 8 pins per port, right? So by setting these TRIS bits, we can make or we can configure particular port pin as either input pin or output pin. Microcontroller ports are usually memory mapped. Some of the ports are memory mapped by writing certain number to a address. You are indirectly writing that to port. So that is called a memory mapping. So even the TRIS, TRIS D, TRIS A, these are having an address in data memory. So when you write certain value to that data memory, automatically that is written to that port. That particular port pin status is changed according to the value that you are writing in that data memory. Right. Ports are usually consist of 8 or fewer bits which often support tri-state logics. Some of these port pins has 3 states. Some of the port pin has only 2 states. 2 states binary state port pin means it can be either high or low. That's all. But in another set of port pins, they have tri-states. What is the third state? Third state is called as high impedance states. If you don't like, see, when you want to use them either input or output, you can use them. If you don't want to use that port pin at all, you can put that port pin in a state called high impedance state. That is also possible. In modern controller has this tri-state logic. Right. So we have to aware of that one. If a port has programmable input and output, it will also have an associated register which specify whether the data is input or output. That's what, as I told you now. So these TRIS registers define whether that particular port pin is either an input pin or output pin. We can configure it using this register. Clear now? Are you clear about I/O ports? Any doubt you have in this?
Answer, could you repeat that high impedance ones?
Okay. So I told a port pin can be either input pin or output pin. Okay now. So these are the when I use it as output pin, I can send output to external world. When I use it as input pin, I can get inputs from outside world and can use it for my process. These are the two possible states for a pin in a microcontroller. Okay, you at present you don't want to use particular pin, but neither input nor output. Then what can we do? If it is in binary state, if we have binary state port pin, we have to keep that either in any one state. Clear now? Either we have to
Yeah.
keep that in a high or low. So either we are using it as an output port or input port. We cannot say that port cannot accept. See, we are not using it. If I give some input to that port pin, when by default that I don't have a high impedance state, if I give some input to that pin, it will accept that as an input. It is by default configured as input pin. Right. If I have by default that if the port pin is high, that is output pin, by mistakenly in my program, if I write some word which makes that pin to high, that will trigger some high state in that pin. Right now, if that is the case, I need a state for my pin, which is called as, it is not used either as a input pin or output pin. So it is unused, not used state right now. So that is called as high impedance state. So even if you give some input to that pin, or when you try to drive it to high, nothing will happen. It will simply state in that high impedance state only. So this helps us to protect port pins when they are not used. Clear about high impedance
Yes, answer.
right now? So that port pin will have some sort of a gate. If you supply particular voltage to that gate, then that pin is enabled. If not, it is in high impedance state. In that time, you cannot use it either input or output. Nothing is possible. Right.